Hello, everyone. Welcome to session 4 of our Build with AI on Google Cloud. Tonight, the topic's all about AI agents. And this is a collaborative effort by GDG Seattle, GDG Surrey, GDG Vancouver, and the Bevy. So I'm the lead organizer of GDG Seattle. We also have a couple of other co-organizers. We have been around since, I believe, 2010, and I have included some of the photos here. Like every year, we will have all kinds of events about Google technology. We have a DevFest, which is our largest event. We always have I/O Extended and also Cloud Next Extended as well. And I have included a link here for you to follow us on LinkedIn. Since this is a collaborative effort, some of you are joining from as a member of the other chapters. So if you're not a member of GD Seattle, feel free to join us. And on to you, Preeti.
Thank you, Margaret. Hi, everyone. I am Preeti. I'm the organizer for GDG City. We have co-organizers too. Um, Now, the picture that's in red, that's the latest. We did our DevFest, and it was amazing. We have been around for 1 year now. Thanks to GDG Seattle, thanks to Margaret for helping us make this possible and collaborate as a community. I also want to thank GDG Vancouver and Burnaby. All of the chapters really helped us reach where we are today. And yes, cheers to all the future collaboration, and I'm excited to learn today from everyone.
Great, thank you very much, Preeti. So we do not have representative from GDG Vancouver and Bevy here, but I'm still showing their screen with their QR code for you to join their community. And after today's event, we'll also share the slides for you to get more details about all the GDG chapters and our talks today. So today's agenda, we're going to have a brief study series overview for very brief, just a minute or two before we go on to talks. The first talk is by Jason Davenport from Google, and second one is Henry from MLGDE. Then after that, we're going to have a Q&A and we'll wrap up. And the same format as before. So the overview. For those of you who have joined us in the past sessions, it's the same thing, overview that I'm going to go over. But I know some of you are new. By the way, which one of you are new here today? Just type it in the chat. And also feel free to introduce yourself, who you are, and where you're from, right? Just type in the chat so we can get to know each other. I wrote this blog post, Google Cloud Skills Boost, back in October. It basically on the Google Cloud Skills Boost, which is a learning platform. At the beginning, there was only 3 Gen AI paths: a beginner one, intermediate one, and the advanced one. And in October, Google Cloud has separated them out into 4 learning paths, which you can see on my sketch notes. I also wrote a blog post here. You can read a link here to go read on Medium. So our study series loosely follows these 5 Gen AI paths, although the session topics are not limited to the Gen AI path. Like, for example, this is the session 4. If you study the Gen AI path, it's all about like data and data science. But today we're actually talking about AI agents. So typically we have a talk by either Googler or MLGDE, and then we go to the Q&A session. So what is a Cloud Skills Boost learning path? A learning path on the Cloud Skills Boost has multiple courses, and each course has videos, recommended reading, quiz, and then hands-on lab. So if you want to work with Google Cloud, typically you have to have a Google Cloud account. But with this learning platform, you can gain access to the lab as if you were studying in the Google Cloud. They give you a student username and password, and then you should have 2 weeks to work through the materials, and it's okay if you don't finish, and feel free to study ahead. And even after our study series finish, you should still have some time to finish to continue to study on it. So I one thing I forgot to mention is about collaboration with Pretty with GDG Surrey, and last year we also collaborated on the Google Cloud MLE Machine Learning Engineer certification and study series. So that was a great experience, and this year we're collaborating on the Gen AI learning path. So access to Cloud Skills Boost. If you RSVP on Bevy, where you register for the event, you should automatically already have access to Cloud Skills Boost. However, if you don't, in the end of today's session, we're going to share with you where you can join a Discord to ask your questions there. All right. So let's start with our first talk. Please welcome Jason Davenport from Google Cloud, and to talk about how to build AI agents on Google Cloud. So, Jason, would you like me to stop sharing so you can share your screen?
Yeah, I can go ahead and do that.
Okay, great.
All right,
So I'm going to stop sharing.
there we go. All right, let me go ahead and just progress here. All right, can everyone see my screen? I think we're good. Cool. So what's super cool is hearing about all the fun things folks here are doing on your generative AI learning journeys. If you think about the things that you're working on now, using LLMs, using data, all these are the fundamental skills as we think about then building things on top of that, whether that's an app or what I'll talk about today, which is more of the AI agents flow for this stuff. So super cool to see that and know that all this learning plus things that in data, things that in application development, it's all relevant and also really helps to build a great foundation for the things that we're about to do, quite frankly, in the agent world here over the next 3 to 5 years. So I took the slide. This is from Thomas's keynote in 2024. And if you think about why agents are really kind of the buzz, even probably more so now than they were in 2024. LLMs are great, right? But really the notion here is, well, how can we build things that actually do just things in order to satisfy the intents that we ask them to do in their process? Take things like data agents. How do we actually empower an LLM to sift through terabytes or petabytes of data to find those actionable insights and do it in a way that's automated or has human in the loop to be able to find those really meaningful nuggets of information in it. Same thing with customer agents, right? These have been around for far longer with customer support, but LLMs continue to change these things. How can we make agents truly personalized for folks like myself, knowing actual bill context, all those things, if I have a bill related question, even to help me be able to order in kind of a non-deterministic way where we're not hard coding every single condition that a bot or an agent has to do. So all of these really culminate, right, in the ways that we have to then go and think about changes to things that we will code and deploy as a part of this agent landscape, and then also how, quite frankly, we monitor it, right? Because monitoring in a non-deterministic world is actually very different than a deterministic world, but it's based on the same fundamentals that we all know and love, from operations today. So all of these really have to be based, first off on things like a platform. So, what are the frameworks that we're building on top of? What are our common application code languages that we're speaking in? Models make a big difference here. We're working hard. Obviously Google loves Gemini and the Gemini variants as a model, but there are a number of ways, right, where you can run even things like Llama 3.3, Claude 3.7, with Google Cloud as your infrastructure for those providers. And here infrastructure, this is really how are we optimizing, right, for the best usage of all of these LLM calls and platforms and training and all that, and making sure that's efficient, right? Because even last year, one of the concerns, right, is, well, why do LLMs take so much usage to make these different calls and all these fun things for it? All right, so let's talk about then. So if we think about kind of the impetus for agents, then the question is really, well, that's fine, right? But what does an agent actually have in it? And Margaret and I had the pleasure of probably talking about this for over an hour about a month and a half ago, which was a super fun discussion. Um, here is, if we think about things that we're doing in generative AI with LLMs, a lot of this really comes down to, if you think of the LLM as kind of the orchestration engine, for the things that maybe an agent has to do. It's also taking everything that we know in application development and then giving that to the agent in order to be able to ultimately be successful with satisfying those intents. So thinking about things like tools that we want to have the agent actually have. Thinking about functions, thinking about the databases that we want to attach this to, and then ultimately other agents, right? Because as you play around more with even session management and LLMs, that context and the session information and the history that you have tends to be overweighted in the LLM's response. And if I'm asking an LLM a question about one of my kids loves Pokemon, asking a question about Pokemon, and then all of a sudden I'm asking a question about Transformers, the context switching, right, it can be very difficult. It's difficult for us as people, right? When my 8-year-old does that, it drives me insane. But that's where we want to make sure that we're setting up intent-based agents that really have those skills to manage different things through it. So that's really the tools pieces, the orchestration pieces with the models. The other things are, if you think through prompt engineering, I call this English literature at times. How are we thinking about ways that we use words that we want to maybe change because they have overemphasis or underemphasis in particular models. Memory is also a concept that I've been doing a lot more with. If you think of an interaction that we have, maybe, or you have with someone, short-term memory, right, is what's that conversation. Long-term memory is, well, okay, but what are the things that I remember about you from a year ago, from 2 years ago, from 5 years ago that are relevant? Agents here are no different. How we have the same memory concepts here is actually very important. And also how we actually think about those conversions from things like working memory to short-term memory to long-term memory, and what those look like. What's cool about this, right, is that if you actually start to break apart all of these flows, though, it really comes back to application development flows. What's the input that I'm looking for? Maybe the middle is I'm using an LLM to do some sort of action, but the output may be to store some piece of information in a database for it. So these things really are just fundamentals, and then how we're packaging them differently in order to create agentic or fully automated agent behaviors in this. Reasoning and planning is probably the last one, and there's been more on this in the past, really 2 to 3 months. Models like Gemini 2.0 thinking, where you can actually see the chain of thought. If I have to solve this problem, what are the 15 steps that I'll go do? Here's the 15 steps. Okay, now go act on those 15 steps. These are really how these are starting to take on more what I'll call kind of human-like attributes. But at the end of the day, these LLMs are really as powerful as the training and then the instructions that we are able to give them for the things that they do. And we can't really underweight that, right? Writing good system instructions or good prompts is a way to yield a far better result in many cases than some of the other methods that we may see applied. All right. So if we think of this, from moving from, okay, well, what is the agent? What are the ways in Google that we're starting to enable that agentic, ecosystem across all the different things that we have for it? And the first one is agent space or discovery engine. Think of this as really kind of that pre-packaged way where you can build the knowledge graph of the information that you have in your organization. So going and taking something like SharePoint, or taking a knowledge graph that you may have in a database or in something like Jira, taking that, summarizing all of the different attributes that are in those, summarizing the information. And this is where we do the things like chunking. So taking the different components of a document, breaking into smaller pieces, turning those into vectors, and then ultimately letting you ask natural language questions of those fun things for it. Next piece is, let's say that's kind of the first thing that we try, but now we want to actually build some more complex flows. We have conversational agents. So for those who are familiar with Dialogflow and Dialogflow CX, think of this as kind of that world. So how are we building those intent or skill-based flows for things where that started off in contact center and all those fun different attributes. These are typically low code to no code agents. So think of this as drag and drop, where I may be playing with some different variables or setting up different conditions. But I can still do things like function calls, right? For things like security, where I maybe have to refresh a token or get a certain piece of user information in that. And then we start to work down to really, what are the developer tools, right, that we have in order to do different things with agents. So first one is the agent SDK. So how we can actually build with code and using the Google APIs to do these different things. We have Agent Engine, or also known as Reasoning Engine, which is essentially a way to do things like deploying a lane graph or crew onto Google Cloud. And what's nice about these is that we'll take care of a lot of the monitoring and the logging and all of that sort of management. So you can really focus on your application or your agent that you'd like to deploy in it. And then, of course, all the different things that you can do with the Gemini API, whether that's just simple turn-based chat to even things like real-time multimodal. How am I in this call using the room, looking at the room, and getting real-time feedback from my agent that my agent may end up taking action on to say make a registration for someone who is not been registered before in it. I can't stress this enough. The other thing that we do value through this, and hopefully you see this in a lot of things that we do, is the enterprise controls. So if you're using Vertex AI for doing development, obviously any of the data that you use or you give Gemini as your data, it always remains your data and stays within your project domain. And you can also do things like fine tuning off that to maybe give an agent or a model a particular tone, or even to fine tune maybe certain questions that it has around things like billing, where there are very specific answers that need to be given on it. So a lot of fun things. What I'm about to shift over to is a couple of repos and an example that we have for running different agents in a playground that we've just launched. But excited, and obviously I think Preeti just posted, but if you have questions, please feel free to put them in the chat, and I'm happy to answer them either here or offline to you as well. So with that, let me go ahead and stop this screen share. And I will shift over to the next window in my roster here, and hopefully we can get this right, because that's always the challenge. I also suffer from Chrome tab anxiety, in which case I have about 75 tabs open. Cool. We can see Holt's a good friend of mine. He does a lot of generative AI videos, and actually a lot of the code here that we're starting off showcasing in this. So first thing here, just for those who are maybe starting to dabble in more of kind of your own journeys in AI after the skills boosts, we have a repo of a lot of great code examples out on GitHub. It's under Google Cloud Platform /generative-AI. And under here, if you're looking for things like what methods can I use with the Gemini API, what are some different things that I can do in terms of full end-to-end examples, I highly recommend coming here and starting with some of these, because while a lot of them are notebook-based, it's very easy to follow along and then to see how some of these different cool features and functions work. And if we looked here, even for things like sample apps, there's a couple of different end-to-ends that we have, and we also have even using things like Llama Index, because Llama Index is taking the world with their chunking capabilities and all the fun stuff for it. The last thing I'll talk about here in a little bit more depth is what we just launched for Agent Starter Pack today. So if we come in here under Google Cloud Platform again, we're at agent-starter-pack. And this is really a couple of prepackaged agents and some different CLI methods to be able to call our Agent Engine API and to be able to both test agents locally, and then really focuses on kind of the life cycle of doing local development to cloud-based deployments for the different agents and things that we have to offer. So the thing here that I also love about everything that we're working on in agents is really the notion that, we may provide some abstractions in the future, but you may choose to use particular SDKs to do all the different things that exist in your world and based on your use cases today. So we do a number of things where we support deploying Crew AI-based agents, where we support lane graph-based agents. And I think there's another one, A2, which is one that I'm less familiar with. But we're continuing to grow this ecosystem and making sure that interoperability here is really kind of the key tenet of the different things that we want to do for it. So what I'm going to show here, just last thing here in our kind of generative AI journey, is a basic agent here, which is a lane graph agent, but has a nice little front end based in Streamlit. And what this agent does, if we were to look at some of the code pieces here very quickly, and I'll make it a little bit bigger here, we can see here that we're actually using just lane graph with a couple different components, but we are using Vertex AI. We're using the Gemini 2.0 Flash model. And then what we've done is essentially set up an agent using lane graph, but using all the methods that you may be playing with in LangChain today. So let's break through a couple of these things just really quickly, because I think once you kind of see these things in action, right, it starts to make kind of this obtuse agents thing, feel real, but also actually very attainable for the things that you do. So first off, we mentioned just a little bit earlier, but one of the things that's the most critical for LLMs, whether you're using a single LLM or whether you're creating an agent, is the notion of tools, right? We can't create cars, as an example, without tools that we can manipulate and use our hands and use other things in order to create them. LLMs and agents are no different. So what are the tools that I need to provide to my agent? In this case, just defining simple functions in Python code for these different things on it. Next here, I'm just giving that essentially tool that we defined is an array. And what we'll do here is we're also going to bind those tools to our agent. And so here what we've done is essentially set up a language model. We've given it some tools. We've given it some also just different settings, like I don't want a high temperature, so I want a more grounded response typically. I'm willing to use streaming, and I also don't want to use a lot of tokens out of the gate. Tokens here, again, being the way that we kind of think about both model input and output, and then the costing of all those activities together. Last, and this is really just the part, if you think of, if you come from a workflow orchestration, so, building an API, a set of APIs, if I go order something, if I go to Air Canada or United Airlines and I hit, buy airplane ticket, in reality behind the scenes, right, this is a set of, anywhere from probably 4 to 15 API calls that get made behind the scenes. And we build those as workflows, which makes it really easy for us to figure out, okay, if something failed, what happened, we have to do number one before we do number two. And LLMs here, again, if we're thinking about agentic behavior, what we're doing is really just defining a workflow of available paths for an agent to be able to take. And in this case, right, this is a pretty simple one. We just have a few different nodes here and an entry point, but we can define that graph and also start to define different conditions that we may want the agent to actually go have. So this is where, sometimes it feels like, in non-determinism, things can really, get out of hand very quickly. But using the workflow type method, like we can actually, scope agents to be able to do things and give it some creativity and some activities, but also, make it really adhere to our methods and our processes and others for it. And I think this one here, is really easy as we think about, our different flows, just, showing how this works for it. All right, so last thing here, so I'll just shift over here. I'm in a Streamlit web browser. We can see here I have different agent types. So we could choose with this React app to use a local agent, which means that this agent would just be running as a Python process on my device. In this case, I've deployed this to agent or reasoning engine. So I've go ahead and given it my ID here, and you can see it's a long nonsensical list of integers. So not something that I'm probably going to remember offhand, but I can grab this from the system if I want. And if I go ahead and hit chat here, we can go ahead and create that new chat, and I'll say, what is the weather? And let's do Phoenix. And we can see here that we're doing a couple different things. This message was hard coded in the LLM for the example, but what we can see in what we did here, we can actually see that the agent said, hey, it looks like we're looking for weather. We had the query here. We had then the tool call that was made, and we saw that it actually called the tool that we had provided to it. So what's great about these, if you're looking to go play with it, is we've bundled a number of different methods also for CI/CD. So when you feel you're ready to deploy this, there's a number of other pieces you can go grab. But it makes it easy to take an example like this and start to test the different tools and functions that you'd like to use for it. So with that, I'm super excited to hear about how everyone is using agents. And I think Harry has a great thing here, which is coming up. But if you have any questions, you'll please go ahead and put them in. And thank you for the time today, Margaret and Preeti. This is super fun to talk about.
Great. Thank you so much, Jason, for the excellent talk. I know the time was very short. It was about a little over 15 minutes, and you went over what is AI agent.
Yeah, it's super fun. Just know that AI agents in some cases can mean anything, but if it has an LLM call, it's probably at least minimally agentic. So we'll get there with the terminology someday, but I'm sure we'll be arguing about it also in 5 years. So it's always fun.
Yeah, and also I'm very excited that you share with us the Agent Starter Pack for Google Cloud, which you mentioned just launched today. So our attendees, you're all lucky that you're hearing Jason's talk today. I'm sure you haven't given that part of the talk before since it just launched today, right?
It's cool. We've got a few things in there, but I highly recommend all this stuff is about the patterns. So there's going to be something in there, hopefully between the two repos that hey, I'm interested in this. Like, let's go figure out some more with it. Use the notebook to learn. Use some of the pieces of the repo for them doing deployments. It's hard to learn both the LLM and agent stuff and have to do all the deployment stuff. So hopefully it makes it easier for folks here to be able to do it.
Yeah. So Jason, about Q&A, would you rather answer the questions about your talk right now, or do we wait until the end? What's your preference? Should we go ahead with questions regarding your talk right now?
I'm good either way.
Okay. And Preeti, are there any questions on Slido for Jason's talk?
I'm checking. I don't see any.
Okay.
Yeah, I don't see any. I think when people use the tools and then they might have. But Alan has a quick question. Yes, Alan, you can type it here or in Slido.
I'm waiting on pins and needles for the question.
Okay. What are the applications of agents in multiple platforms?
Yeah, so fun question, right? We could take it a number of different angles. I think in terms of like business value. So one of the things that I think about is like, what are the use cases that are really helpful for agentic behavior? And interestingly, if for folks here who have not done this before, if you've looked at robotic process automation in the past, this is something where it's like there's a number of use cases, right, for doing things like invoice processing, procurement, all these kind of big workflows that require somewhat specialized behavior in terms of being able to look at a document, find information, take that, do something with it. So the first place I kind of start is coming back to is like, what are things that improve like the customer experience, or those things that improve the ways that the organizations operate. In terms of then how you can kind of compose agents, a lot of these frameworks are actually pretty interoperable. Even Crew AI has an example in one of their GitHub repos of how you can use LangGraph and LangChain tools with Crew AI as you create your crew of agents to go work together. So like I would say the agents, in terms of being integrated, it's kind of one of those like you can pick, how integrated or not you'd like them to be. But it's good, to think about, okay, well, what are all the things that you would want the agent to actually be skilled at? And then does it make sense for it to do that? And this is where I always come back. I mentioned a little bit earlier to, what are human skills that we may have? And like I'll use Margaret and myself as example for a minute. Margaret's very into fashion and all these things that quite frankly like I'm terrible at. Like I don't know the first thing about it. Like these things are like it's just very foreign to me in terms of like the different like concepts and things that I have to know. My background is really in like finance and data science and all that stuff for it. Do I want to make all of that one agent? Probably not. Because if you think of the context switching that the agent has to do, if one person had all of that information, like it can be a lot in order to manage those different pieces across. So, here's like you can build things that are different, but just make sure that they're integrated. And this is where memory then in working space is okay. How do they share things together? Like, Margaret and I might share a chat in terms of the different things, that we're working on for it. So, human interaction here is really, interesting, right? And it's like, it's like kind of fun to think, okay, like what's old is new again, right? Like person to person interaction. It was, I guess, old in the world of TikTok, but it's definitely new again when you think about, agents. And I even saw the last thing is like I saw someone talking about, well, do you manage agents like you manage employees? And I was like, in 3 years, like that might be a thing where everyone is a manager. And I'm like, crazy connotations, right? But like also
So we're
like
not
very
managing
possible.
humans anymore in a few years.
But you have 10 agents and like one of them is like having performance issues. Like it could very much be something that happens in the future, and how we manage that is also very interesting.
Yeah, great. Thank you very much, Jason. I think there's another question, but we're going to hold off on the questions till the very end, and let's move on to the next topic, Henry. And thank you so much, Jason. If you don't mind, could you stay around, or are you gonna?
Yeah, I'm gonna stay on. I'm gonna drop off video to make sure that my children are in bed, but
Yeah,
I will be listening in.
yes, and then join us for the
Yeah,
Q&A at the
I'll be
end.
right back.
Thank you very much, Jason. Talk to you later. Now, everyone, please welcome Henry. And Henry is MLGDE, and he'll probably give himself an intro who he is. But I want to introduce him also as my friend. That as part of the MLGDE community, we have collaborated on multiple projects over the years, and I'm super excited to welcome Henry here today for our session, and again to talk about agents.
Yeah, thank you so much, Margaret, for the invitation. I'm really excited about to talk uh, this about specifically about this topic that is, it's right now it's a boon and everyone is trying to figure it out and understand how this actually works. And this is my plan for today. I'm gonna try to go through like a few slides, trying to touch in some of the concepts that is gonna help you to understand better the kind of demo that I'm gonna present. But at the end, I promise that it's gonna be focused more in the code and try to explain uh, the like agentic framework that you can easily uh, uh, implement by yourself. Okay, so should I share my screen or?
Yes, please. And you have presenter mode. You should be able to share your screen.
Okay, so let's get started. So my talk today is about. Okay, let me see if I can. I think that I gotta just move on this. Okay. So my talk today is focused specifically in an application of agents. I'm gonna try to touch into a little more advanced topic, which is multi-agent collaboration to solve problems. So I work as a research scientist at the Texas A&M University, and I have been trying to understand how these agents work and the different mechanisms behind of these models to be able to trans transfer from a natural language text instructions into something that you can actually use to make decisions. And so this idea of that the agents, they can actually reason, they can actually plan and use the information that you provide to them to be able to do different automation or be able to do different tasks. So I think that had opened the door to different applications today, specifically to automate some of those repetitive tasks that we generally do every day. And those models are getting better and better in different tasks like mathematical reasoning, logical reasoning, and right now the sophistication of the fine-tuning techniques that you can apply in these models had actually made these models improve and be better. So, as Jason mentioned, so agents are pretty much extended vision of the generation and taking advantage of LLMs, large language models, uh, capabilities to process natural language tests. So they can actually extract meaning and transform these prompts into instruction that you can actually use to orchestrate your pilots. And this is what actually this is the main difference between a LLM application and an agent. That you're gonna provide the agents with the way to hold information in the memory, but also be able to act out of the environment and be able to kind of uh, run code in the backend that let the LLM to extract information. So from different sources. So you can see here. So the input for our agentic system is going to be just a prompt, but the agent is going to have different tools and it's going to have memory that allow the LLMs to hold information into the context, and all of this information they gonna go to the LLMs, and based on that, uh, the LLMs can actually make decisions, and you can use that output to orchestrate your analytical pilots. So this is one example. Imagine that you ask what is the weather today in San Francisco. So probably like the LLM itself, they're not going to be able to access to that information because they were not trained with this kind of data. They don't have access to real-time data. But so something that you can actually do is that if you have something in the backend that is able to call an API to grab the information from the weather, so you can provide that information into the agent scratchpad, which is it's kind of like the system message of the LLM, where you can specify that like you're a helpful assistant with access to the following function, use them if required, and so you can take advantage of the context windows to provide information to the LLM to do this kind of thing. So at the end, if you provide in the context that you have something in the backend, in this case, a function that could be implemented in Python and other kind of language. So the LLM is going to figure it out that probably what you are attempting to do is call that function to get that information back. And then, so this is what exactly what the LLM will do. So it's going to return the information about after the reasoning process, it's going to return, okay, there is a function that is called get weather, and these are the arguments. And because those models have been trained to understand language, they can actually extract uh, information, and they can actually extract uh, entities from the text. And in this case, the LLMs are smart enough to be able to identify that you are asking for the San Francisco locations. You can pass those arguments to the function, and then you decide what do you want to do. You want to execute a function, or you want to call an API, or you want to do something else. And at the end, that information is going to get back into the context, and this is what the LLM is going to use to generate the final response. So this is kind of the workflow of one of the different agentic patterns that exist. This is specifically about tool use. But when the complexity of the application is start increasing, so you probably need to rely on the collaboration of multiple agents working together to try to understand like the problem, and also try to come with a plan and provide with a way to automate this kind of tasks. And depending on the kind of task that you are trying to automate, well, you have different options to put these elements together, and and the, uh, and those agents can actually collaborate themselves to be able to solve problems. And in the way that they actually do is that uh, they can interact each other, sharing information and adding all of this information into the system memory, and that information can be used for the agentic system for automate different tasks. So, as I mentioned, when the complexity of the application start growing, where there are some tasks that you need to have more than one agent involved. When you have specialized agents with different tools, you're probably going to need to have framework that facilitate and help you to the implementation of this into a production environment. Like something that provide with the building blocks that you need to develop and implement this multi-agents application into a production environment. So this is some of them. But what I will show today, this is the link to the. You can scan this QR and it's gonna take you to the code. I'm gonna briefly show you an implementation of a multi-agent application for that somehow can help you to find in the job hunting search. Like pretty much what we have here is that we have two agents. One agent that is gonna get as an input your CV, and this gonna start information about the CV, and that information is gonna be passed into the other agent, and the other agent is gonna use that information to try to find online some of the job offer that match with your profile. And we're gonna call this function, and then once the agents finish trying to solve the task, so we're gonna bring the memory to see what the crew of agents working together hold, which is pretty much the information that I expected to get as an output. But something what I want to try here is that what you're gonna find in this GitHub repository is a from scratch implementation. So that means that there is no any framework involved in this code. So I'm gonna try to go to the if the time allow me. So I'm just gonna try to go to some of the main components. And this is also kind of like make a recall that sometimes or in some application, you don't really need to have a framework to be able to automate tasks. And even using multi-agent applications to solve, like in this case. In this case, I only have two agents, and I don't probably need to have a library to be able to automate this kind of stuff. So as I mentioned, I have two agents. One is the job categorizer agent. So as an input, I'm gonna pass to the agent my CV. This is the file. This is the PDF with all my information and so on, and my recent experience. I'm gonna pass that to my agents, and I need to specify which model. This is really important because for this particular task that the agent is gonna try to solve, you need to have multi-model capabilities and be able to understand PDF documents. And also you need to specify some parameters like max iterations and termination condition. So under the hood, what actually happening, like what the agent does is just internally try to figure out how to solve a problem. And this is just like an iterative process that it could be finished based on in the condition that you decide. And most of the framework that you see there, like LangGraph or QAI and all of these frameworks, you need to specify this kind of thing, which is going to be the termination condition, or some of them already have that implemented. But pretty much the termination condition here is that the agent is going to try to generate an output. If the output doesn't match with the output that I expected to get from this particular agent, he's going to try to do another iteration until it reaches out that these conditions actually is true, So then this is the name of the model that I'm gonna. This is the name of the agents, the models, number maximum of iteration. This can be another alternative termination condition. And this is the agent, the scratchpad. You are a job assistant, categorizing jobs. I need to pass the API client, which is the object that I'm gonna be using to talk with Gemini. And this is the task that I want to automate. Review my CV and provide a list of jobs. Titles that match with my profile. And this is some of extra configuration that I can pass to my agents. For instance, I want to take advantage of Gemini structured output to get the list of the job titles that I can potentially apply based on my job, on my profile. So I have defined this schema, job category. This job category have just a title, a description, So what is going to happen under the hood is that so the library is going to do the conversion. And I'm gonna have another agent that is gonna use one of the other features that Gemini has, which is Google Cell Grounding. And what I'm gonna do with that is that I'm gonna use Gemini Flash. So you're gonna find the job listing matching user profile. And the task that I want to automate is extract the job titles from memory. Look at that I emphasize here that I'm gonna extract that information from memory because we have two agents working together into the same crew. That means that they're gonna have access to the same memory. So what I expected is that when this agent finishes his task, so he's gonna write in the memory the list of the job titles of the job categories. And this is the information that the other agent is gonna be using for go to Google and try to search some of the jobs offer that I can potentially apply, and it's gonna grab the description, the company, the salary, and so on. And here I am passing other information. I specify what kind of tools I need for this particular agent. And in the implementation, I take advantage of some of the operator of Python and to highlight the interaction between these two agents. What I wanted to say here, or the meaning of this is these agents, the output of this agent is going to be received by the outputs of the other agents. And this is one of the different multi-agents patterns that you can see out there. So this is the more kind of simple one, which is like a chained multi-agents interaction, or you can also call like a sequential interaction. And I just call the kickoff function and I get the output. So if I run so what is going to happen is the job categorizer agent is going to start trying to find the information. So then it's going to put that into the memory. So then this job set agent is going to grab that information from the memory. And finally, it's going to show me the list of all the potential applications that I can apply. You say that I can apply to research scientist position, or I can apply to full stack software developer, or data scientist, or research assistant, or full stack software developer, or adjunct lecturer, or graduate student intern. So this is some of the advice that the model actually gave it to me based on my input, and he actually provide information about so how could be the salary of this position, the possible location, and the possible location and description. But what I wanted to emphasize is that this is from a scratch implementation. If you really want to understand how this agent works, I highly recommend go and check this code. So as you can see here, I implement this class. So this class is just a simple abstraction of how the memory and the agent work. So as you can see, I can just here this is an example of how to use this class. So you can have multiple entries in the memory, and they're gonna be grouped by the section name. So as you can see, this is the output. And the reason why I create this object is because I'm gonna have one section that the agent is gonna populate with the job categories, and another section where the other agent is gonna populate with the job post and position that I can potentially apply based on my profile. So then there is another abstract class which is called verbal agent. It's a very simple class that have two functions: use tool for use output. Use tool means that this function is going to be called when the LLMs even attempt to execute a function to get information from the environment, or if you want just to process or do something with the raw output of the agent of the LLM. So you can use this function to implement all your logic. We're going to have this function called LLM generate response and start task. And as you can see here, the sequential crew is just a list of agents, right? And every time that I pass a list of agents to this sequential crew, I'm just gonna create this member sheet with this dependency injection here. So you see that these agents belong to this crew. And this is gonna be important because this is through the reference is where agents in the crew, they're gonna be able to access to the memory. And finally, I'm almost done. So I have an implementation of a Gemini agent that inherit from that verbal agent. And the only method that actually changed here is the way that I call the APIs. So this is supposed to be an abstract class that can be extended if you want to create a custom agent for OpenAI or for other kind of LLM provider. But here for this particular example, I use Gemini, so I need to change in the way how I actually call the the LLM itself using the API. This is kind of like what actually changed when you call the model. And this is probably the most important part to understand in agents, the agentic loop. You have a for loop that defined the number of iterations that the agents can potentially. This is kind of like the reasoning step. So the agent is going to try to figure it out uh, how to select a specific task, and you need to define which going to be the termination condition to break or like skip this loop. And at the end, what you expect is you're just going to get the output. And if it's a function call that the LLMs need to do, it's going to call this function use tools, and otherwise it's going to call the use output function. And this is the function that start the task. And as you can see, it's just calling this function here, which is the agentic loop. Just to finish, so here I create two agents, and these two agents extended from Gemini agents. And the only thing that I actually change is what I'm gonna do with the output that the model give it to me. So for instance, in this case, for the job categorizer agent, so what I'm gonna do is just update the crew memory, and I'm gonna add the entry with the list of all of the jobs that the agent is able to find. And in the job service, it's gonna do the same thing, but I can actually extend that to call, like an API or so on. But the key here is that remember that you always need to update the crew memory. That means that the agent is gonna be access to that information. So this is all of this code is available in GitHub. So I highly recommend you to go and check it out. So I actually emphasize here that this is a from scratch implementation specifically for education purposes. But if you want to do something more sophisticated, so just go and use one of those frameworks. Okay. Thank you.
Great. Thank you so much, Harry, for the talk and the great demo. I know due to the time constraint, you went through your demo like super quick. I just have a quick question. How do you the app or the tool does some sort of analysis of a person's resume and then go on searching for jobs that matching the particular resume or the user profile, right? Where do you like input that file?
Yeah, this is with Gemini is very straightforward because Gemini already have the document understanding. So that means that when you see here, when I define the agents, so I just make sure that I use a multimodal model. And here I am passing as the reference to my PDF. And
The PDF?
Yes.
Okay.
So this is the PDF file that I am reading.
So I see. You just execute the script and then you put the file as a part of your repo, right?
Exactly. This is
and then it will read that PDF.
This is the entry point, and this entry point is that I just read this PDF and I pass to the agent. The agent is going to extract the information and update the crew memory, which the crew is just the group of agents working together. So then the next time when I ask the other agents to go and extract the job title from the memory, he knows that I am referring to the memory of all the multi-agent crew, So, so this is
this is really a developer experience, like
yes,
a developer will play with this. And
the reason why I want to do this implementation is because it's really important to understand how this agent actually works under the hood, because you can go and use one of those frameworks as I mentioned, but there is a lot of tasks that you don't really require to have like a framework to be able to automate it by yourself using the state-of-the-art models. Like some people is using the agents to do, like using framework to do task summarization or using frameworks to do task summarization. Like you don't really need to have this overhead of installing a extra library to be able to do these kind of things. Like you start relying on these kind of frameworks when the patterns of your agents collaboration start growing. When you have 3 or 4 agents. Now the question is, you probably are asking is yourself is why I need to have multiple agents if I can have only one agent that do everything. Well, there's a lot of publications that have shown that when this context window of these LLMs start growing, so they start losing the need. That's mean that the needle. So that's mean that it's better to like a divide and conquer when you split the problem in different agents, because it's gonna maximize that you're gonna get the output that you expected. Rather
Right.
than
So it's like a team where each team member has a different roles and responsibility. You have these multiple agents who fulfill that.
a single agent start having tools and tools and tools and tools, this can easily get confused what tools you call or so.
Okay, great.
So I think we are saying that make one agent a specialist of whatever they are doing instead of just giving them 10 tasks. Just make them specialize in one task.
Exactly.
Yeah.
So this is one of the insights that this is
Okay.
one of the recommendations to do. Like try to do light agents rather than that have an agent that have like 16 different tools.
Right. Perfect. I already forked uh, the repo because I think it's really interesting and it could be very useful. Apart from the fact that LinkedIn does not make it very easy to use the API for job searching,
In
Yeah.
the meantime, it's like the job post here is relying of the grounding capabilities of Gemini. So even though it's important to mention that sometimes the links that the Google search bring are broken. You try to go to the
Yeah,
website and it doesn't work. But
right. But it would make a very good tool if expanded. But yeah, this was great. We do have some questions. Whenever you're ready, I'm going to share the screen.
Yeah, feel free to share the screen, Pretty. Thanks.
Perfect. All right. Believe this was for Jason, the first one.
Let's see if Jason is back or not. I see Jason's camera is not. Oh, here's Jason. Hello.
Hi, Jason. This first one was for you. Do you specialize SQL structures for logical JSON structures or rather JSON code?
Sam, I probably need you to clarify that in the chat if there's a specific thing you're looking for in terms of like LLM, like input or output. Yeah, generally a couple things. If we're talking about JSON, so language models, like in particular Gemini, can do things like have controlled output. So what that means is, hey, you're going to force a specific like JSON structure for some of the things that come out of it. SQL is a tough one because if you think about taking like a SQL statement as example. One of the things that large language models actually struggle with the most in that is that there's typically code and business context, and the business context is undefined. So as you think about ways to give LLMs better ways to utilize SQL in it, consider that metadata here is actually probably the most important thing to think about. So like, what are the table descriptions? What are the column descriptions? Like those are the things that if we looked at a table, just as an example, in BigQuery, you have 25 columns. Like, well, I know that like this column is used sometimes and this other column is used most of the time. The LM doesn't know that unless you give that context to it. And the way you would do that is either with descriptions, and whether you place that as like a JSON based like metadata payload or something in the SQL thing, it's probably a trial and error thing to see what works best for your use case. So I hope I answered it. But if you have more questions, obviously, please feel free to ping me directly for it.
Thank you. Thank you. Second question is, in a multi-agent scenario, are the agent interactions supporting bidirectional variables? Can we run multiple agents asynchronously? I believe that's for Henry.
Well, this actually depends on the kind of patterns that you are trying to implement. In some of them, you can actually, because the interaction model that you are trying to develop using multiple agents are low, so you can actually have these agents running asynchronously. But for instance, in the kind of a scenario that I just showed, it's a sync scenario because you need to wait for the output of the previous agent to be able to run the other one. But definitely you can do it. And this is somehow related with the next question. So the good thing about these LLMs, well, at least Gemini allowed uh, multiple function calling at the same time in parallel. That means that this gonna help you a lot to be able to kind of do multiple functions asynchronously to get information into the context. But at the end, so the objective of the function calling mechanism is to provide the LLMs with the act. You pretty much have these three act agents where you just take information from the context, and based on that information, you can uh, grab data from the environment. I mean, the way that you actually do it, you can do function calling to call an API to get information from a database or so on.
Awesome. Thank you so much. I believe the second one, this one was already answered in this, so I'll just scroll. I'm not clear what is the meaning of iterations and why it's a loop statement. Is the same query being run several times?
Yeah, this is exactly what happened. This is you can call it like the reasoning loop because in the first iteration, for instance, the model couldn't get the output that is expected. So that means that it's gonna try to make another iteration until you get into the point that the termination condition reach out. So that means that is big. You can actually say in the scratch pad of the agents, whenever you finish the tags, add the word terminate into the context. And you can actually use to indicate that the agent successfully finished the task, and this information can be used for other agents to keep working in other uh, automation. So this is why you have this loop.
Perfect. Thank you. What steps would translate databases curated by a logical AI and a creative AI like Imagen? Would transcription be necessary?
Can agents be used for label the data with? Yeah, I think that with function calling, you can actually automate this kind of tasks. Like data annotation and these kind of things because you can call in the backend another model that identify the objects, and the model can actually help you using object detection, for instance, to automate the process of labeling images. But at the end, you need to have a pre-trained model that is gonna be a tool that the LLMs is gonna be able to access to. However, there are the sophistication of the multimodal models enable them to understand images. So that means that some of them, at some level, they can actually help you to automate this labeling process. But the problem with that is that if there is a very specific application when you are working with uh, X-rays or images from, like remote sensing or other kind of images where it's a very specialized kind of object that you are trying to label. So in this kind of a scenario, you're probably gonna need to fine tune the model, but you can do that using uh, multimodal models. Like
Lovely. Thank you so much. I'll move to the next one. Sorry. Okay. Can agents be used for data annotation and label the data with ontology terms as well as the correct query for, sorry, I don't know that term for the ontology term.
yeah, I think that is the same of the same previous question.
Yeah, so they can. Here one of the things to consider is what's the the upside and the downside risks of things, in terms of being labeled, incorrectly, as example. But in terms of labeling, like there's a number of things that even like Google Research has done in terms of like medical research, where we're using large language models that are typically fine tuned for the use case. As Henry mentioned, right, where it's going through and saying, hey, based on these prior samples, here's a classification or something of like an MRI image, as example. This is where what's nice about these things is you can fine tune and say, hey, here's the samples, and then here's what we're looking for on it. You can also pass in or use either long context windows or RAG to give the actual like ontology list. So hey, here's the specific term. Here's what this term represents, and then let the LLM use that as input when it's going through and classifying different images and those sorts of things for it. Because it's medical, like would typically recommend some human in the loop, right? You may have if we're using kind of the agentic themes, you might have one agent whose only mission is to actually classify and perform data annotation. You may have an LLM kind of as a judge, in which case we're giving the judge LLM different system instructions and still giving them access to the dictionary, but asking it to critique how the annotation was performed on an image to maybe find discrepancies. And then typically post that, right, that's maybe where we get to kind of the human in the loop feedback, which is, okay, here's the things, like, does this, check out, for some sample, anywhere from, a percentage to 100% of images, depending on the use case for it. So you can definitely use agents for this. Like it does fit agentic behavior. You can do things like perform the annotations asynchronously, because as the files come in, right, we just want an agent to process it. Which makes that part really nice, actually, in terms of being able to then use that data moving forward. Or you could do it in batch, right? Human initiated, but it's kind of choose your adventure at that point.
Thank you so much. Yeah, this is amazing. This was the last question, so I'll just stop sharing unless anybody has a question. But I think we should take just one more and we can move on to the Google Cloud Skill Boost, Margaret.
Yeah. Do we have any more questions? If not, we can.
Not on this slide.
Yeah, let's just move on to the Cloud Skills Boost real quick. And actually, I don't think we need to do a walkthrough. Perhaps just show the screen of the Discord for GDG survey,
Right.
and then we can wrap up with the last page. Do you want me to share screen or?
Yeah, that would be great.
Okay, I'll share my screen. So let's see. Yeah. So if you anybody have any questions, just post them on the GGG Surveys Discord server. And here's the link, and we'll share the slides later on. I'm pretty just share the link. So we hope you have fun studying, and hopefully you already have access to the Cloud Skills Boost. If not, just post your question on the Discord. And then our next session is in 2 weeks. And then we will be talking about ML Ops. Aside from our session, I will post the link as well. Google Cloud team is actually also organizing a build with AI in Seattle about agents. And it's a hands-on workshop for like 6 hours on March, I think it's the 18th. Yeah, like the day before our session, which is March 19th. So, well, I would like to thank our presenters. Thank you so much, Jason, for joining us. And thank you, Henry, for joining us. And thank you, everyone, for attending. And good night.
Thank you, everyone. Good night.
Thank you. Bye.